everyone for joining us today for 500 million years at Weedon Island. And hopefully this talk won't take a full 500 million years. I think we'll try and fast forward on that a little bit. Basically, we're going to do a crash course in the evolutionary history of some of Florida's wildlife. So evolution and fossils, they're two of my favorite things. So much so that I actually had a copy of this poster that's in this slide here that was hanging above my bed in college. So today we'll be embarking kind of on a journey through time, and we'll be covering, kind of cramming actually, 500 million years of evolutionary history into less than an hour. So let's get going. So most of you watching are probably familiar with Weedon Island Preserve in Central Florida. But since this presentation is online, some of you might not have visited the preserve before. Weedon Island consists of a beautiful stretch of coastal mangroves and boardwalks, along with some more upland pine and palmetto sort of habitat. And it's home to an incredible variety of plants and animals, from birds and gopher tortoises to flowers and bugs and butterflies. Some of these creatures are relatively new arrivals to Florida, while others have seen very little change over millions of years. And we'll kind of sort out which are which throughout this presentation. So this little chart here, it's pretty intimidating, but let's talk about it briefly now. And then at the end, we'll kind of circle back to it, and it should hopefully make a bit more sense. So for our purposes, you can kind of ignore this left sort of third of the image here. Let's just focus on the numbers and the key events. So these are millions of years ago, with the most recent at the top, and then oldest stuff happening at the bottom here. So basically, we start, the earliest evidence of life 3.5 billion years ago back here, just about 1 billion years after the Earth formed and started to cool. But for the first couple billion years, this was very primitive, slowly evolving, merging into cells and tissues. The fun really begins in the last billion years, when everything is diverging and becoming more recognizable. And really, the most recognizable diversification event happens here with the Cambrian Explosion, about 500 million years ago, where we're going to start our journey. So this period of time, known as the Cambrian Explosion, within the Cambrian period, basically we now see fossils from about this time, 500 million years ago, that show early body plans of sponges, corals, starfish, worms, shells, arthropods, and even the earliest vertebrates. And so this is kind of the earliest time where when you see a fossil of an organism, you can actually start to see what it is going to turn into. You can kind of put it roughly into a group that we still have today. So 500 million years in the past, we've got the earliest evidence of fishes. At this point, they're still jawless, without any of these specialized fins. They definitely don't look much like the fish that you'd see today below the boardwalks at Weedon Island. But they probably don't look too different from modern day hagfish or lamprey. Something, here's an artist representation of kind of a, boneless looking sort of fish. Not super recognizable like some of these that you have in Florida, but this is when the fish start out. At this point, we also have the early arthropods, which you may know. The arthropods include things like insects and crustaceans. Arthropod basically meaning jointed limb or jointed foot. So all of those things with the little jointed legs, from spiders and butterflies to crabs and lobsters, are arthropods. They haven't yet diverged into these groups that we commonly know, the crustaceans and insects, yet. But you can already see they've got these little segmented legs. They've got these segmented antennae here. They look kind of like little modern shrimp, maybe some sort of insects a little bit. But at this point, pretty much all of the life on the planet is confined to the water, to the ocean. But let's fast forward about 50 million years. 450 million years ago here, the plants start to break free of the water. And one of the first types of plants are liverworts. And here we've got some brown and some green liverworts on a branch. These are actually at Brooker Creek Preserve. They often go unnoticed, but they're actually extremely common throughout forested areas in Florida. Relatively simple little plants growing along bark around on rocks, possibly, is how you usually see them. Same time, now that the plants are starting to colonize the land, now there's an advantage for other creatures to follow. If it's just barren rock, there's not really much of a purpose in going onto land, but plants provide food and shelter, and the arthropods soon make it onto the land, with some of the earliest fossils looking kind of like millipedes here. And then in the water, horseshoe crabs have pretty much evolved by this point. There are things like trilobites that look very similar, but horseshoe crabs are already very similar to how you would still see them nowadays on the coast. Okay, almost 100 million years have passed since the first land plants and arthropods, and now we start seeing mosses and the earliest of amphibians. These first amphibians were essentially a cross between a lungfish and a salamander, breathing air, starting to turn their fins into walking limbs, but they still had to lay their jelly-like eggs in the water, so they're still very much tied to water here. But just 30 or so million years in the future from that, the evolution of hard-shelled eggs allows vertebrates to break free of the water. Now they're fully able to live on land. So around this point, lizard-like reptiles are emerging, mostly evolving, from an offshoot of something that looked like a salamander. Now that slimy skin has been replaced with this scaly skin, and so both the skin of the animal and the shell of the egg are able to, survive in dry air, which means we can colonize the land. 300 million years ago, we get two of the most widespread plant groups on Earth. We got ferns and conifers, like the pine trees. So in fact, these early forests of trees, once they fossilized and compressed underground, turn into coal deposits. So when we dig up and burn coal, we are literally burning the carbon from these ancient forests. And that means, many of the best places to find plant fossils around the world are also kind of near the productive coal mines, such as in Pennsylvania. Still moving forward here, 250 million years ago, we're into the Permian extinction. So the Permian age ends in the greatest mass extinction the planet has ever seen, with 70% of all terrestrial species and 96% of all marine species going completely extinct. But when some creatures go extinct, that makes room for new ones to evolve. So 250 million years ago, an offshoot of the reptiles diverged and became the dinosaurs. So the age of the dinosaurs here, it lasted almost 200 million years. So there were dinosaurs around for longer than the time span between when the dinosaurs ended and now, which is kind of interesting to think about. During this time, we start to see many dinosaurs looking more and more like birds. So we're starting out with sort of a lizard body plan, got crocodilians and things here. But the more derived, the more advanced, some would say, dinosaurs would be, bipedal. They would have feathers, and they're starting to look more and more like birds. But we still don't really get modern birds for a little while to come. 250 million years ago, same time, beginning of the age of the dinosaurs, but also is the beginning of lichens, which, maybe not as big and impressive as the dinosaurs, but they're still very diverse, very beautiful. And you can, still see them nowadays all throughout Florida and across the globe. Okay, here, the dinosaurs aren't the only things evolving right now. We've got turtles and crocodilians taking shape. Here we've got two of the modern species that you'd have in Florida, soft-shelled turtle and a little alligator here, next to some of their fossils. And you can see how little they've changed. This soft-shelled turtle fossil is actually only about 50 or 60 million years old, but there have been turtle fossils and tortoise fossils for about 200, 250 million years. And then, of course, the crocodilians have not changed very much in a very long time. 150 million years ago, We're halfway through the reign of the dinosaurs. And now we begin seeing complex feathers and basic wings. But these animals, they still have teeth and claws on their front limbs, but they are looking more and more bird-like. Of course, there are actually a few species of birds that retain some level of digits or claws on their forewings, like where they have actual wings. So write in the Q&A down below if you think you know of any examples of modern day birds that still have any sort of digits or claws. And at the end of the presentation, we'll return back to this. Same time, a bunch of the insects are now emerging, and by 150 million years ago, they look remarkably similar to modern day species. Here, a dragonfly that looks almost identical to one from 150 million years ago. And then still in the water, many fish are evolving that look remarkably similar to today's fish, or are the ancestors to modern fish. There are many places in Central Florida where you can see the gar, such as below the boardwalks at Brooker Creek Preserve or at Sawgrass Lake Park near Weedon Island. But being freshwater fish, you probably won't be seeing them at Weedon Island specifically, which has mostly salty and brackish waters. But the next time you see them, stop and think about how little they've changed in 150 million years. These strong armor-like scales that now help protect them against things like herons and alligators probably first evolved as a defense against dinosaurs or other early crocodilians. And those defenses have been so perfect that they really have not had any pressure to change their body plan very much in 150 million years. Moving ahead a little bit, 100 million years ago, the dinosaurs are still around, but now we get a very important novelty: flowers and fruit. With the evolution of flowering plants, things like butterflies and bees are able to evolve and diversify. Before this time, we had those ferns and conifers, and there were some other types of tree ferns and plants, but we really didn't have what we would call modern day flowers and fruits. Nearing the end of the dinos, at this point, alligators and crocodiles have pretty much perfected their design and diversified, spread around the warmer parts of the world. And our alligators have pretty much remained completely unchanged since about 80 million years ago. So we've been focusing so much on the plants and animals, we kind of breezed over the fact that the continents haven't actually been where they are today. This is what Earth looked like about 80 million years ago. So here we've got South America and Africa kind of hanging out together. You can see those two puzzle pieces fit nicely together. Australia is way down here, stuck to Antarctica. Florida, if you can see in here, it's completely underwater. Florida doesn't really exist yet. We're kind of a shallow sea at this moment in time here. Okay, 65 million years ago. This is the date everybody knows, either from school or from all the Jurassic Park movies. About 65 or 66 million years ago, a large meteor smacks into the Gulf of Mexico and sets off a climate change event that wipes out all the large dinosaurs on Earth. However, remember that some of those dinosaurs were small and feathered. Instead of going completely extinct, some of those little dinosaurs were able to survive and diversify into the birds. So it is not a stretch or a metaphor to say that birds are dinosaurs. To borrow from Randall Munroe, the ingenious creator of XKCD comics, it is a completely true statement to say the fastest animal on the planet is a small predatory dinosaur known as the peregrine falcon. With the non-avian dinosaurs gone, there are a lot of new niches available. And we not only see the diversification of birds, but of many mammals and snakes as well. Also, we have the diversification and spread of the first mangroves. I took this picture at Weedon Island a few years ago, but the scene may not have looked very different, honestly, about 65 million years ago at other mangrove forests. Because the oysters that are stuck to the prop roots here, they had already evolved by then. So this could be a scene 50, 65 million years in the making here. That hasn't changed very much. Okay, 60 million years ago, dinosaurs are gone. Mount Everest is starting to rise because the Indian plate is kind of smashing into the Asian plate here. And so they're kind of smashing together and pushing together, and Mount Everest is just starting to rise. But at this point also, we have manatees evolving from an herbivore, a terrestrial mammal. And this is 10 million years before seals or whales. So manatees and dugongs were actually some of the first marine mammals. And it took an extra 10 million years before seals and whales would re-enter the equation here in the sea, kind of evolving on a parallel line from other terrestrial mammals. And if you ever go fossil hunting in Central Florida, either at like Peace River or near Venice Beach, some of the most common fossils that you will find are going to be from an extinct dugong, kind of an ancestor or cousin to our manatee here. And these fossils are so common because these creatures had really, really dense bones, which are very, very strong, and they survive this weathering process. And so they fossilize very, very well. And they have these dense bones to counteract how buoyant all of their blubber is. So these big fat marine mammals, the manatees, that's their insulation. And if without these dense bones, they'd just be kind of bobbing at the surface. It'd be difficult for them to swim down. And those dense bones make it very easy for them to fossilize and be found even today. So we had flowers 100 million years ago, but now at 50 million years ago, we get an incredibly beautiful and diverse group starting to emerge, the orchids. These butterfly orchids can be seen from the boardwalk at Brooker Creek every summer. And I know they were blooming not too long ago. I saw on Facebook they posted about that. So if you go take a walk around Brooker Creek this weekend, you might still get to see these guys in bloom. And then I just love looking at some of these old fossils and how incredibly similar they are to modern species. Here's a crayfish that I photographed in Florida, and here's a 50 million year old fossil looking almost completely identical to modern day crayfish. It's just incredible. And the same goes for, damselflies. You think of these delicate little critters, and it's incredible that some of them were actually able to fossilize and be preserved for us to find 50 million years later. So by this point, 50 million years ago, all of the current major groups of insects have evolved. We've got grasshoppers, we've got dragonflies and damselflies, we've got butterflies, we've got bees. They're all out there. If you went out, with your butterfly net 50 million years ago and you were catching bugs, you could put them in pretty much the same groups that you would know today. So this image here shows the phylogenetic tree of all the bird families of the world. And there's way too much detail to see anything at this view. So let's just zoom in on one piece, and that's better. Now we can see the years at the top here, kind of left to right, starting 65 million years ago here on the left to modern day here on the right. And so we can see, if we go along this tree here, this yellow bar at about 30 million years ago, by this point, we've got pretty much all of our current families of birds already evolved and split. So if you hopped in a time machine and you went back 30 million years ago, you would see birds flying around that you could probably identify to family, herons, owls, kingfishers. And then by 10 million years ago, you'd really be able to recognize pretty much all the birds that you saw. Woodpeckers, hummingbirds, toucans, ducks, they would all be recognizable and similar enough to modern day species that you could go birding 10 million years ago and have a good idea of what you're seeing. Oh, and if you recall, the hard-shelled amniotic egg from the lizard that first evolved over 300 million years earlier, when the lizards finally broke free and we have reptiles, that was a very, very long time ago. So the next time some wise guy asks you which came first, the chicken or the egg, you can inform him that the egg came way before the chicken. Okay, let's jump ahead. We're getting closer. We're in the home stretch now. 5 million years ago. The sea levels are up a bit, which also could be like 100 years in the future, but that's a whole nother lecture. Florida is mostly underwater. So if you go looking for fossils in Florida, a lot of the sediment that was laid down about 5 million years ago is, it's about this old, a lot of places. And so you can find shark teeth, marine fossils. I found these little shark teeth in central Florida, far away from the coast. But because Florida used to be underwater, you can find these marine fossils in streams and rivers. And they're quite common out there because there were so many sharks over so much time, and sharks have so many teeth that we're not in danger of running out of little shark teeth anytime soon. Still creeping forward here. Now we're around 2 million years ago, and a few big things really happened here. So humans, they're finally around, not in Florida yet, but they're still confined to Eastern Africa. Maybe a little bit hairier and shorter than most of us nowadays, but we're getting there. Closer to home, though, Central America rises up a bit, and the sea level drops a little bit. And so you have North America and South America, and they are united for the first time in a really long time. And that means that all the critters that evolved in South America here can start moving north across this new land bridge. And then the same goes for North American critters that can now walk south. And so that means mammals like porcupines, opossums, and armadillos start expanding their range into North America from the south. And cats like bobcats and mountain lions, and dogs like wolves and foxes, and the bears, they all started in North America, and they can creep down through South America now. And this is known as the Great American Interchange, this sort of 2 million year old time where these continents are finally meeting up. Okay, we're out of the millions and into the thousands. So we're 200,000 years ago. Humans are now expanding out of Africa, and the sea level has fallen enough that Florida is now actually twice as big as it is today. So now we've got this big peninsula here with the green here showing kind of the rough area where Florida would be. And so at 200,000 years ago, we're at this stage, and here are the players on the stage. We've got an incredible array of the Pleistocene megafauna. So the Pleistocene is this age about 200,000 years ago, and we've got things like mammoths. We've got mastodons, which are basically giant hairy elephants. We've got giant ground sloths. We've got giant armadillos the size of a small car, cave bears, dire wolves, saber-toothed cats. These are all roaming the forests and plains of North America, including Florida. And they are still there up to about, a lot of them are still there up to just 25,000 years ago. But now here we're nearing the end of the Pleistocene, and humans are showing up in Florida. Humans have migrated out of Africa, through Asia, across the Bering Strait, into North America, have made it all the way down to Florida. And now that we're here, well, the result of humans showing up with their fires and their stone tools and their big brains, in a geologic timescale, the result is pretty much the immediate extinction of all the Pleistocene megafauna. Mammoths, the camels, the ground sloths, horses that we had here natively, all directly or indirectly pushed to extinction by the people that showed up. So you can still find here, I'll go back one, you can find these fossils though in Florida. This here is a horse tooth, and here these are chips of mastodon tooth here, and you can find these in central Florida. I found these near the Peace River. Okay, skipping ahead. Now we're getting into modern times. Here we go. We've exited the prehistoric times. Europeans have crossed the Atlantic and they've moved in, and one man obsessed with William Shakespeare, this guy named Eugene Schieffelin here, he decided that America would be a better place if it were home to all the birds mentioned in Shakespeare's plays. So he played a pivotal role in introducing two of the most invasive and detrimental animals into the United States from Europe, the house sparrow and the European starling. And both of these species have now pretty much taken over and are abundant across the country and throughout the whole continent, actually. So that was an interesting choice to introduce those birds. And a few decades later, a traveling circus brought armadillos from Texas, and they were either released or escaped. But either way, that is one of the first introductions that actually took hold of armadillos in Florida. So remember, back in that Great American Interchange 2 million years ago, the species of armadillo basically made its way all the way from South America up through Central America into Texas, and then stopped right around Louisiana, pretty much around the west side of the Mississippi River. But around 1920s, 30s, and 40s, now these animals have people moving back and forth, and they're able to finally cross big bodies of water very quickly and settle places. So around the same time that we have the armadillos introduced, we have shipping containers moving between Florida and the Caribbean, which brought the brown anoles and the Cuban tree frogs here, which are now completely abundant throughout Florida, and many of them have spread northward up into Georgia and beyond. And actually more recently, I don't have a slide for it, but even more recently, we have, of course, the Burmese python introduction in the Everglades, which is now, wreaking even more havoc on the native mammals and birds down in South Florida. So here we are back to today at Weedon Island and throughout Florida. There's hundreds of species of animals that you can see and enjoy. They haven't always been here. The tree frogs and the toads were stuck in South America until the interchange 2 million years ago, whereas the leopard frogs and bullfrogs, green frogs and pig frogs, they've called North America home for millions of years, and now many of their ancestors have more recently kind of spilled over into South America. And then, of course, with this slide here, the Cuban tree frog, as I just mentioned, he just joined the party in the last century or so. These butterflies and moths, they've been around here for 100 million years, but even in this group, there are some that have more recent stories. Picking out one here, the fulvous hairstreak here, kind of in the center of this slide, that's from the Caribbean, and it didn't really historically live in Florida until humans brought its favorite plant, the Brazilian pepper, in the 1970s. And so that, now that its food, its host plant was introduced to Florida, the butterflies kind of made their way up and followed. So it doesn't just have to be that, we bring an animal, and then it gets introduced. If we bring the wrong plants, other animals can sometimes have an easier chance, gaining a foothold here that aren't supposed to be here. As a side note, just here, one of my favorite butterflies that you can find, and you can find it right at Weedon Island, is the mangrove skipper. It's this shiny, deep blue guy here in the upper middle of this big old compilation I did. And then, of course, we have the birds, our living dinosaurs. In the past 50 million years, they have evolved specialized bills for feeding on everything from seeds to flowers to fish, and crazy colors and patterns that are just simply beautiful. And of course, got to point out, roseate spoonbills, one of my absolute favorites, and another common one that you can find if you hike down the boardwalks at Weedon Island. They are just a really special bird with their really crazily adapted, spatulate spoon-shaped bill for sifting little organisms out of the water to feed on. So we've covered a lot today, very quickly. So let's quickly recap some of the major events of Earth's history. Life starts over 3 billion years ago here, eventually getting more and more complex. 500 million years ago, we've got those fish and the very beginning of those arthropod body plans. 250 million years ago, land plants, we've got bugs, amphibians, we've got lizards. Just at the beginning of the age of the dinosaurs here in the 240 million year old range. 100 million years ago, we've got dinosaurs, we've got flowering plants, lots of insects that we would recognize. But we would also be starting to see, let's see, well, we still don't even have the orchids yet 100 million years ago. But then if you fast forward to, let's say, a million years ago, most of the plants and animals are pretty recognizable, but we still would be seeing mammoths, saber-toothed cats, things that have just very recently, in the scheme of things, here, have gone extinct. And then all the way back to the present, we've got our familiar birds, butterflies, mammals, fish, flowers, and everything in between.